Hi everyone. So last time we talked about the different types of tissues. Now we're going to take those tissues and we're going to kind of combine them to form something called membranes. And we're going to spend most of our time this module talking about a very particular type of membrane. But first, let's go over the 4 different kinds of membranes that there are in the body. Now remember, these are epithelial membranes, so they are primarily epithelial tissue, but they also incorporate connective tissue. But because they are epithelial tissue, we're going to be covering and lining the different parts of the body. There are 4 main types of membranes. We have serous membranes. Now, serous membranes are going to line cavities that are not open to the outside. So we're going to be lining cavities that are completely enclosed within the body. These would be things like your thoracic cavity, which includes the pleural cavity around the lungs and the pericardial cavity around the heart, and your abdominal pelvic cavity below the diaphragm. We learned about those the first week of class. Now, serous membranes produce a fluid called, conveniently, serous fluid. Now, why do you think you would want to have fluid in those cavities around your organs? Well, if you think about it, all of these organs are moving constantly. Your lungs are inflating and deflating, your heart is beating, even your digestive tract organs are moving around as they contract to squeeze food along through that long tube. So we need to have a little bit of fluid in there to help lubricate those tissues so we don't get them stuck to each other. I like to think of serous fluid as the oil in the engine of your car. If I don't put oil in the engine of my car, then my parts are going to seize up, they're not going to work properly, and the engine is going to fail. So serous fluid is going to help to keep the organs moving and keep them lubricated, just like the oil in the engine of your car. Now, mucous membranes are a little bit different than serous membranes. Mucous membranes are going to line cavities that are open to the outside. So here we're going to line cavities that are open to the outside. And they're going to produce a fluid as well, and they're going to produce mucus. Now, why would I want to have mucus lining these cavities that are open to the outside? Well, I want to help protect the underlying epithelial cells that are lining those different cavities. And we'll talk more about the different cavities and that would have mucous membranes lining them in a little bit. Cutaneous membranes are also known as skin. So that's where we're going to be talking about our integument today during this module. Now, cutaneous membranes don't make cutaneous fluid, but your skin does make fluids. What fluids does it make? It's going to produce things like sweat and oil, and of course, if you're lactating, milk. The last kind of membrane that we have would be our synovial membranes. And synovial membranes are going to line synovial joint cavities. Now, we have not covered joints or synovial joints yet in this class, but I want to ask you all a question. I want you to think of any joint in your body, and I want you to just kind of jot that down in the side of your notes. So pick a joint, any joint. If you need to, pause the video while you're writing it down and then come back in. All right, now I'm assuming that you've picked something. I'm not a great mentalist, I can't read your minds, but I'm willing to bet you that you picked joints like your shoulder, your elbow, maybe your wrist or finger joints, maybe your hip or your knee or ankle joints. Now, the reason that you probably picked those is because those are joints that are really movable. So we're used to thinking about them because we're moving them all the time. Every single one of those joints that you probably picked are synovial joints. These are the most movable joints in our bodies, and therefore they're going to be characterized by a synovial cavity that is lined by a synovial membrane. That synovial membrane is going to produce fluid, and I think we've learned the rule by now that it's going to produce synovial fluid. Now, why would you want to have synovial fluid in your joints? Same reason we want to have serous fluid in those cavities. It's oil in the engine of your car, so we need to keep those parts moving smoothly, and therefore we need to have fluid in them. Now, as you age, a lot of stuff starts to break down and things don't work properly. Most of the textbooks that are out there like to talk about in each of the different systems, all of the different things that change as you age. And those are great to read, and there's a lot of really good information in there. But if you had to take a wild guess as to what happens as a particular body system ages, there's a really good rule of thumb you can use, and that is that as you age, you in general tend to do less of the things that you were doing. Now, that's not always true. Sometimes you start to do too much of some things as you age, but in general, activities in the different systems start to decline with age. So, if you think about these different membranes, as you age, your synovial membranes are producing less synovial fluid. So then what's likely to happen? You're likely to get grinding of the joints, wear and tear of that cartilage that's in there, and then you end up with wear and tear arthritis, which is what I have in my feet and my thumb, which is called osteoarthritis, which literally basically means wear and tear arthritis. You just beat on your joints. As you age, your cutaneous membranes tend to produce less sweat and oil. So when you're older, you might have a harder time with temperature control. And you also might have a harder time keeping your skin moist and keeping it intact. So you're more likely to have drier skin, and it tends to tear, and you tend to have breaks that allow bacteria and things to get in. In addition, with your skin, this is, remember, stratified squamous epithelium. So there's layers and layers and layers of those flat cells. And you're constantly regenerating and replacing old skin that sloughs off all that dust in your house. As you age, you replace the skin more slowly, so your skin layers get thinner and thinner. And that's why if you've ever been around Grandma, you might have noticed that maybe she's got what feels almost like tissue paper thin skin. And it's one of the reasons why when you have elderly people who are more sedentary or on bed rest or just are immobile and therefore stuck in their beds, they might be more likely to have bed sores because that skin is so thin and fragile compared to what it was when they were younger. Now I'll come back to mucous membranes in a second. As you age, you tend to produce less serous fluid, so you're more likely to have issues with your organs kind of irritating each other because there isn't that nice lubrication of oil in there. It's not really oil, but you get the idea with the engine of your car. So you've got this irritation of these adjacent organs that are constantly moving next to each other. And then if we kind of finish here with mucous membranes, as you age, those mucous membranes tend to produce less mucus. So if you think about mucous membranes, these are cavities open to the outside. So you're talking about your digestive tract, or I like to call your digestive tract the donut hole, because if you think about a donut, there's a hole in the middle, right? And I can put something on the table in that hole, and it's not technically out here in the donut. So you can eat something and it goes into your donut hole that starts at the oral cavity and goes to the anus. It's not really kind of in your body yet because it hasn't been absorbed into the donut. So we're going to have a mucous membrane here lining your donut hole or your digestive tract. You're going to have a mucous membrane lining your respiratory tract, your nasal passages. And then you're going to have mucous membranes lining your vaginal canal and the kind of end of your rectum, of course, is part of that digestive tract, so that's all part of that donut hole. So again, mucous membrane. Since you're producing less mucus as you age, then if you think about your respiratory tract, you're more likely to get things getting into your lungs that shouldn't, so you're more likely to get upper respiratory infections. You're more likely, if you are still sexually active, to end up having micro tears in the vaginal lining and therefore transmission of diseases of some kind. It's something that probably a lot of people don't want to think about, but if Grandma retired to the, what is it called, the Villages in Florida, I think, near Orlando, is one of the largest retirement communities down there, and they have a higher incidence of STDs than in the general population. And part of that has to do with decreased mucus function or production. So those are your 4 different kinds of membranes. Now let's take a look a little bit deeper at serous membranes. So we said already that serous membranes secrete serous fluid. Now we already learned about these terms, the pleura, the pericardium, and the peritoneum, right? We learned about those back when we did terminology. The pleura means lungs, so these are membranes around the lungs. The pericardium means the heart, so these are membranes that surround the heart. And the peritoneum is your abdominal pelvic cavity, or those abdominal organs. Now in each of these 3 different areas, there are 2 layers of serous membrane. There's a visceral layer and a parietal layer. The visceral layer is tight to the surface of the organs, and the parietal layer is either lining the overall cavity or it's forming a loose sac around that organ. So when we look in each of these different areas, we can have a visceral pleura or a parietal pleura. So the parietal pleura lines the thoracic cavity, and the visceral pleura is on the surface of the lungs. You can have a visceral pericardium, which would be tight to the surface of the heart, or a parietal pericardium, which forms a loose sac around the heart. You can have a visceral peritoneum, so that would be on the surface of your abdominal organs like your intestines, or you can have a parietal peritoneum that lines the abdominal pelvic cavity. So let's take a look at a couple of these different membranes with some images here. If you look in this cavity here, this is my thoracic cavity. So this overall cavity here is going to be lined by a parietal pleura. When I look at my individual lungs, here and here, we're going to have one lung on this side, one lung on this side, and they're going to be covered by a visceral pleura. My heart is kind of located right in here, and if I just do kind of a crude drawing of a heart here, there's going to be a membrane tight to the surface of that heart. So imagine that that's right on the surface. And then it's continuous with a loose sac around the heart. So the membrane that's tight to the surface is going to be the visceral pericardium, and then the loose sac is the parietal pericardium. And if I look at my abdominal pelvic organs, this overall cavity is going to be lined by a parietal peritoneum, And then all of these organs that are twisting around in here are going to be covered by a visceral peritoneum. In addition, there are some other membranes and mesenteries and things that actually kind of help organize those organs in your abdominal cavity. There are some cavities of the head, we mentioned those before, but you're going to focus on those more when you get to skeletal system. We'll talk a little bit about some of the ones in the skull, and when you get to things like respiratory and digestive system.